This is how to make the Omron PLC a Modbus client, and Sysmac unfortunately does not make this easy. A lot of PLCs have built-in functions. Sysmac chose to not do that. So basically we need to open a socket, send our read, send our write command, close the socket. It's not hard, it's just a little tedious. So in order to make this reusable, we're going to start with a function block ladder. And we'll just do this FB for function block and Modbus. So a couple variables to get us started. We'll do execute as our main input and done as our main output. We're going to need the IP address, which is a string. We'll need the Modbus read command, Modbus write command, read data, write data. And then we want to keep track of if it was successful or error. Is success, is error. So when it is, so we'll basically give it the execute to start the Modbus, read, write, all that. When it's done, we'll get the done, and it can either be done on success or done on error, and you can handle that accordingly in your code. So our success and error will both be outputs. Our read command is an input, and it is _s modbus read. Write command is _s modbus write. Read data will be a array of word. And these values, the array lengths, I'm kind of making arbitrary. This is actually just from my last project. I'm doing this. One of the another downfall of doing Modbus in Sysmac is that if you are using a function block, you have to define the length of the array in the function block. You can't use like the any type. You can't make this a variable length array, which is really frustrating because that basically means you need a new function block for every array length you use. If anybody knows how to avoid that, I would be very happy to know how you did it. But in the meantime, this is the best I have. And then we will have our read data will be an output. And the rest, I think, is cool. All right, so we're going to do this as a sequence. So there's going to be steps, like defined steps, and that's how we handle all of our read, write, Modbus commands. So there's going to be several internal variables we'll need. So these are just relevant to the function block. You will not be able to see them anywhere else in your program. So the first being step, Modbus step, so that's what step we're on. And I think the rest we'll do as we go along. Yeah, we'll go as we go along. Okay. So the first thing it's going to be is your execute. So this is when you give the function block the go command. When this happens, we will start our sequence. So we'll move, I like to work in 10, so instead of going step 1, 2, 3, 4, we're going to go 10, 20, 30, 40. That way, if you ever need to add anything later, it's easy to kind of insert it in between. So we're going to move the value of 10 into our MB step. So basically, when the function block is triggered, we start our sequence. We start on a new step. And just to be sure this isn't started twice, you can do a compare. So let's make sure we're on step 0. Let's make sure MB step is step 0. Send the execute. If it's step 0, we move to step 10. So next step will be 10. So copy the equal. If MB step is 10, then the first thing we want to do is open our socket. So to do that, we have socket TCP. Take a look at that. Socket TCP connect. So leave source TCP port empty. It's gonna. You can put a number here. You can put like 502 or something. For me, it's caused problems, so leave it empty. Your destination will be your IP address. That was our input variable. Destination port for Modbus is always unsigned int 502. And this busy error ID, we'll worry about that later. Or maybe I'll leave that up to you to worry. We'll see if we have time, but good to keep track of. Not needed for this video. And the socket, we'll just name this the socket. So this will be internal. And you can see it created this internal variable, socket underscore s socket. You got to give a name, so I just do prefix it with FB TCP connect. So a couple ways you can finish this off. So this kind of works the way our whole function block will work, where we give it an execute. It does its thing on the rising edge. You don't need to hold it open because just the rising edge will trigger it, and you'll get the done when it's done. But I think what we're going to do is go right under here, normally open. So when socket TCP connect done, so when this triggers, we will move to step 20. You can also wait for an error. So you can do fb socket dot error. If there's an error, we could move to, like, we're going to call this 97, and you'll see that step later. So this is open the socket. All right, next thing we want to do, clear the buffer. So if there was anything left in the data transform, you want to get rid of that. So this will be step 20. We will do the skt clear buff. Socket is the socket, that's the one we just opened. FB socket clear buff. All right, we'll do this the exact same way. This is going to be clear.done. And you're going to move to 30. I think this needs to be here, not error. That is error. That's what we need. So if it's done and no error, 20. If it's done and there is an error, 97. We'll do this the same way. So no error, error, copy. Yeah, let's make this 97. So same thing. We are on step 20 after finishing this. Go to step 20. Execute will start the clear buff, their function block. When it's done, this will go up. No error, go to 30. Error, go to 97. Wonderful. Another kind of useful thing for your diagnostics is to get the status of your connection. So, step 30, which we came from right here, we're going to do skt get status. So, same as before, give it the socket fb underscore get status, and when you're done, fb socket get status dot done. No error. Go to 40. If there is an error, well, let's do it this way. Go to 97. So same as we've had so far. Step 30, run this socket, or I'm sorry, run this function block and wait for it to be done. When it's done, no error, go to step 40, error, go to 97. All right, I think you're getting the pattern now. So next thing we're going to do is read from server. So go to step 40. we're going to do a Modbus TCP read. All right, the socket. And this one, of course, a little bit different because we got to give it some data. So the unit identifier, we're just going to do a unsigned int 1. We're going to give the read command that is our input that came from here. Modbus read command, I'll show you how to do that later. But basically this is all it tells you which function code you're doing, the length to read, the address, all the information you need for a typical Modbus read command. The read data is going to go in our array, which we call read data. Again, that was one of our inputs, read data. Timeout, if you want a timeout, put it here. If you don't, leave it out. I think that's good. You'll need, I don't know if you need read size, but this is what it actually read. I don't think we actually need that. So I'm going to leave these blank. Again, it's probably good practice on your end to fill all these in and handle accordingly, but for the demonstration purposes, unneeded. So like we've been doing so far, Modbus read, cool. Modbus read.done. If we get an error, fb modbus read.error. I totally named these wrong. This should be, there we go. And that should be this one. Sorry about that. Come on. Alright. Okay. Connect. Clear buff. Get status. Wonderful. Okay, Modbus read error. And same as before, move, but we want to go to 50. Okay, when there's no error, go to 97. No, whoops, I had that backwards. No error, go to 50. Error, go to 97. Cool. Alright, next thing we're going to do is write to server. Again, if you want to put in logic, if you're only reading or only writing, or if you just don't want to write every time, handle accordingly. But demonstration purposes, I want to try to keep this as simple as possible. Every time we're just going to open, read, write, close. Alright, we are on step 50. Let me make sure. 10, 10, 20, 20, 30, 30, 40, 40, 50, 50. Wonderful. Okay, Modbus TCP write. Just like before, the socket, the identifier is just unsigned int 1. Now we had Modbus write command. Again, that was from our input output write command, and then we had write data below it. So write data. This we don't, it's not an output, like, the read is because you need the input output if you only change some of the data. But for write, we're only writing, we don't care in this sense what comes back, so it's only on one side. FB Modbus write, and of course, FB Modbus write, not done. And I gotta make sure I did this. Get status, clear buff. Connect. Okay. Right, Modbus write done. Then we need FB Modbus write error. Okay, if there is no error, we go to 60. If there is an error, we go to 97. Cool. Okay, so now we've done our read, we've done our write. So let's do kind of just an intermediate step to set our bit. So if we made it here, we can consider we did a successful read and write. So read, write, successful. If we are on step 60, basically we can say is success set, and if for some reason is error was on, we'll reset it. All right, then we will move to the next step. So go to 70. Okay, but before we continue on too much, we're going to make our step 97. So if we're on 97, which we would have gotten here if we got an error anywhere else. So anytime a function block was done and the error was true, we moved to 97. So on 97, we want to close the socket, essentially. But we also want to keep track of it. So we are going to do an increment. We're going to create a variable error counter, internal, int, and we're going to add to it. Also kind of important that if we had a successful read-write, let's move a value of 0 into our error counter. So on success, error, this will be read-write error. So on error, our 97, increment our error counter, and we will go to, oh, you know what we need to do? Set our bits. So we will reset success. We will set error. And I know we had this go to 70. We're going to bump it up to 100. So we're going to go to 100. And then we're also going to go to 100 after we set our bits, accounted for our error. Go to 100. So if we're on step 100, we just need to close the socket. So we'll do a socket close. All right, the socket. FB, socket close, cool. And then really, either way, whether this finishes or not, you want to just end, whether it's successful or not. So we're just going to do FB socket close dot done. And we're going to move to a value of 0. So that resets it. And we will set, done. So we'll set that as, all right, here. And then when we started, we need to reset done. So when you start, this is low, goes through the process, high when it's done. So it's possible to get your done signal, and we've already set our reset and our error. So that'll be it for the function block in here. This has been pretty long, so we'll do the testing in another video. All right.